Okay, so in this explainer, we're not just going to talk about writing Python that works. I mean, that's the first step, right? No, we're going to level up. We're going to talk about writing code that is truly Pythonic. You know, code that's not just effective, but also elegant and just feels right to other Python developers.
So, let me ask you this, and be honest. Do you write Python or do you write Pythonic Python? Yeah, it sounds like a small difference, but trust me, it's a huge deal. It's the difference between just getting the job done and really speaking the language. You know, using all the cool built-in features that make Python, well, Python.
And this whole idea isn't just made up, it's baked right into the language's philosophy. It's all there in what's called the Zen of Python. You see quotes like this: "Beautiful is better than ugly. Simple is better than complex." And look, these aren't just fortune cookie sayings, they're actual practical guidelines for making your code better.
All right, let's dive in. First up, we're going to look at some super simple patterns for cleaner code. Seriously, these are foundational habits that you can start using like today, and they will make a huge difference in how readable and solid your code is.
Okay, so let's look at a classic example, handling files. We've all written code like this, right? You open a file, you do your thing inside a try block, and then, and this is super important, you make sure to close it in a finally block. It works, it's safe, it prevents resource leaks if something goes wrong, but you got to admit, it's a little clunky, a bit wordy. But what if you didn't have to worry about that finally block at all? What if you never had to remember to close a resource again? Imagine if Python could just handle all that cleanup for you automatically. Wouldn't that be nice?
Well, it can, and the Pythonic way to do it is with the with statement. Look how clean this is. The with statement basically sets up what's called a context manager. All you need to know is that it handles the setup and the cleanup automatically. As soon as your code leaves that indented block, for any reason, success, an error, whatever, that file is guaranteed to be closed. It's just so much simpler, safer, and way easier to read.
All right, next tool in our kit, assertions. Think of the assert statement as a contract with your own code. You're basically saying, hey, at this point in the program, this condition has to be true. If it's not, stop everything because something is seriously wrong. Now here's the key. This is for you, the developer, to find bugs. It's not for handling things like bad user input. Why? Because assertions can be turned off in production to make things run faster. So use them for internal sanity checks, not for data validation.
Okay, let's talk about underscores. At first, they can look a little weird, but they're actually like a secret code that Python programmers use to talk to each other. A single underscore at the front, like underscore var, is just a friendly hint. It means, hey, this is for internal use, you probably shouldn't touch it from the outside. A double underscore, double var, is much stronger. It actually tells Python to change the variable's name to avoid clashes when you're working with inheritance. Then you have the dunders, double underscores on both sides, like underscore init. These are special, magical methods that Python uses. Don't invent your own. And finally, a single underscore at the end, like var underscore, is just a simple way to use a name that's already a Python keyword, like class underscore. Learning this stuff is like becoming fluent in Python.
Okay, now for a concept that is absolutely fundamental to being a great Python programmer. Let's talk about functions. And I mean really talk about them. Because to be Pythonic, you have to stop thinking of them as just little blocks of code you can call.
Here's the mind-blowing idea. In Python, functions are objects, just like a number, a string, or a list. They're first-class citizens. What does that mean? It means you can do things like this. We're not calling the yell function here. Notice there are no parentheses. We are literally assigning the function itself to a new name, bark. Now bark and yell are two different names for the exact same thing.
And since they're objects, you can stick them in data structures. You can have a list of functions, a dictionary of functions. How cool is that? You can see here we have a list with our bark function and a couple of built-in string methods. This opens up some really powerful and flexible ways to design your code. But this is where the magic really happens. You can pass functions into other functions as arguments. This is what we call a higher-order function. Look at greet. It takes one argument, func, which it expects to be a function. Then it just calls it. The greet function has no idea what that function will do, it just knows it can be called. So we can pass bark into it, and boom, it works. This is the secret to writing incredibly flexible and reusable code.
All right, let's switch gears and talk about data structures. Specifically, let's talk about one of the workhorses of Python, the dictionary. Now, Pretty much everyone uses dictionaries, but there are ways to use them, and then there are the Pythonic ways, which can save you from a lot of headaches.
So, tell me if this sounds familiar. You've got a dictionary, you try to get a value using a key, but the key isn't there. And what happens? Bam! Key error. Your whole program just crashes. It's happened to all of us. So what's the graceful way to handle this?
Well, the clunky way, which you see on the left, is to first check if the key is in the dictionary with an if statement and then get the value. It works, but it's two separate operations. The Pythonic way is so much better. Just use the .get method. You give it the key you're looking for, and you also give it a default value to use if the key isn't found. One line. No crash. It's clean, it's safe, it's just better.
Whew! Okay, we've actually covered a ton of ground here, right? From managing files safely all the way to thinking about functions as objects. The next step, the real goal, is for you to take these ideas and start using them in your own projects.
So let's do a quick recap of your new Pythonic toolkit. First, for anything that needs to be opened and closed, use the with statement. It's just safer. Second, use assert to find your own bugs, not to handle user errors. Third, learn the language of underscores to make your code clearer. Fourth, and this is a big one, remember that functions are first-class objects you can pass around. And finally, for dictionaries, use .get to avoid those nasty key error crashes. These aren't just little tricks, they're fundamental patterns for writing really great Pythonic code.
So I'm going to leave you with a challenge. Go look at some code you've written recently. Which one of these tricks is the first one you're going to use? Which one is going to make your code just a little bit cleaner, a little bit safer, a little more Pythonic? Give it a try. Thanks for hanging out with me.